Today we're going to look at net ionic reactions. So when we put two solutions together, they don't always create a reaction. And we know this when we did our types of reactions back in Unit 5. So you need to have page 6 of your reference tables handy. What we look at in net ionic reactions are just the things that are actually reacting. So in our example picture here, we have sodium chloride. Sodium chloride is aqueous, so it breaks into Na plus and Cl minus floating around in the water. Silver nitrate in the second beaker also breaks apart because it's soluble, and so you have silver ions and nitrate ions floating around. When we mix those two things together, we switch the partners, and then what we see is that the silver and the chlorine come together to form a precipitant. Remember, precipitant is a new solid that is formed. The sodium and the nitrate ions, in the meantime, remained aqueous, so they're still floating around in the water. So a net ionic reaction shows just the ions, so Cl minus and Ag plus, that are reacting to form that solid precipitant. Now, there are two types of double replacements. There's the precipitation reactions, which this is an example of, and then the acid-base neutralization reactions. So we're going to look at both of those and write out net ionic reactions. Now, these ions that are remaining aqueous in the solution are called spectator ions. So they're just watching the other ones come together to form the solid. The steps for writing net ionic is the first thing you want to do is write your reaction like you would, following that pattern on page 6 for double replacement. Then you want to use your solubility rules on page 6 at the top to figure out if it's a precipitant or water is formed or if things are aqueous. Then you're going to write the reaction only showing the ions that form the solid. So ions will be our reactants and the solid will be our product. And then the other ions, the things that made up the aqueous product, will be our spectator ions. We're going to look at 3 examples. So here we have silver nitrate reacting with potassium iodide. First thing to remember is you can't do anything in words, so you need to have ions. So silver we know is Ag plus 1. So I'm going to do all the crossing charges up here above examples. Nitrate ends in ATE, so it's a polyatomic. So we look on page 7 of our reference table, and we see that it's NO3 with a negative charge. Remember, the 3 goes inside the parentheses. Then we're going to cross our charges. Since they are both 1, it is just AgNO3. Then we have potassium iodide. So potassium in group 1 is plus 1. Iodide in group 17 is minus 1. We cross our charges and we get Ki. Then we look on page 6 at the double replacement and we see that the pattern AB plus CD goes to AD plus CB. So A in our problem here is silver. So silver still has that positive charge. And then D in the example, or in this problem, is iodine. I still has the negative 1 charge. So when we cross our charges, we get AgI. Then we look at C, which is potassium, still with the plus 1 charge. And B is the nitrate ion, which still has the negative 1 charge. And we cross our charges. Then what we need to do is look at our solubility rules. So we're using page 6, and we're going to label things aqueous or solid. Remember, it's based on the anion. So nitrate, if we look at the rules, it says all nitrates, and the word except is not listed. So anytime you have NO3, it is going to be aqueous. And then we look at our iodide rule. All chlorides, bromides, and iodides are soluble except if they're with silver, lead, or mercury. Well, we're with potassium, so it's going to stay soluble, so we put aqueous. Moving to the product side, we're still looking at that iodine rule. All iodides are soluble except silver. So here's one of our exceptions. So now instead of being soluble, it's insoluble. So we put S for solid. So there's our precipitate. Nitrates, again, there's no exception, so it's going to be aqueous. Now what we want to do is we want to write the net ionic reaction. So we find our precipitate, which is our solid, and we're just going to copy it down again in a new reaction. Then we're going to look at what ions, what did we put together, what did we cross our charges with to get that solid. So we can go back up here and we see that it was silver +1 and I -1. So those are going to be our reactants. Ag plus and I minus. Then we're going to list the ions that are not in our net ionic, but that are up here. So we can go to our aqueous product and we can pick out the 2 ions that make up the aqueous product. They're remaining aqueous. They're not doing anything, so they're spectators. So we can see from our crossing charges work that it was K +1 and NO3 minus. So our spectator ions then are potassium and nitrate ions. Make sure that you're putting charges with the spectators and the reactants of your net ionic. Let's look at another example. So here we have copper 2 chloride. Remember, the Roman numeral is the charge that's on the copper. So that's Cu +2 because of that Roman numeral. Chloride, IDE, is an element. It's in group 17, so it's -1. And we're going to cross our charges. So we get CuCl2. Then we have ammonium phosphate. Ammonium is the only cation polyatomic. So on page 7, NH4, remember that subscript goes inside the parentheses. Positive charge just means a +1 at the top. Then we have phosphate, ends in ATE, so it's a polyatomic. So looking on page 7 again, we have PO4, the subscript inside, and then the charge 3- on the outside. Then we're going to cross our charges. Because we're bringing the 3 down, we need parentheses to remain around the NH4. Because we're bringing the 1 down for the PO4, that doesn't need parentheses anymore. You're more than welcome to leave them in parentheses. Following the double replacement reaction, we're going to have our copper, which remember is a +2 from that Roman numeral, and then phosphate from page 7, which is a -3, and then we're going to cross our charges. This time, since we're bringing a 2 down, we have to leave those parentheses around the phosphate. So we have Cu3PO4 2. And then we have ammonia and chlorine coming together. Now, this subscript on the chlorine doesn't belong to the chlorine. The 3 on the ammonia doesn't belong to the ammonia. So we're not bringing the subscripts. We're just bringing what it is. So NH4 is ammonia +1, and then Cl-, and we cross our charges and we get NH4Cl. And you can balance it if you want, but because I know we're doing the net ionic, I'm going to skip that at the moment. And we're going to look at our solubility rules and just label aqueous and solid. So all chlorides are soluble, copper not an exception, so it's going to be aqueous. Phosphate, all phosphates are insoluble, and then there's some exceptions. Ammonium, is an exception, so that's now aqueous. However, copper here in the product is not an exception, so this one will remain insoluble and it is a solid. All chlorides are aqueous. Ammonia is not an exception, so this remains aqueous. All right, so the next thing we do is find that precipitant and bring it down. So our solid this time is copper 2 phosphate. So we're going to rewrite the reaction with this product only. Now, what 2 things did we cross our charges with? That's what's going to be our reactant. So we can come back up here to our work, and we have Cu +2, and we have PO4 -3. So those are our 2 reactants. Now, this reaction is not balanced, so we do need to balance it. We need 3 coppers and 2 phosphates. So we're just going to put a 3 and a 2 in. Now, for the spectators, we go back and look at our aqueous product. Whatever I used to make this product that remained aqueous would be spectators. So that's our ammonia and our chlorine. All right, one last example. We have sodium hydroxide. So sodium, group 1 plus 1. Hydroxide, remember, is one of our polyatomics that doesn't end in ate or ite. So it's OH and then a -1 on the outside. Don't forget to put OH in parentheses. Cross our charges. We have NaOH. So I didn't write the parentheses, but it had that sodium had a charge greater than 1. I would have had to have them. So just don't forget. Then we have hydrochloric acid. So because we see the prefix hydro, I know that the chloric is the element chlorine. Since acids always start with hydrogen, I know I have the H plus, and then I have the Cl minus. Because of the prefix hydro, I know that that chloric meant chlorine, the element. Cross my charges and I get HCl. It's still a double replacement, so we're following our same pattern. This time we're going to put sodium and chlorine together. They both had a charge of 1, so it's just NaCl. And then we have C, which is our hydrogen, and B, which was our hydroxide. So we're going to cross our charges, and we would get HOH. Now that looks a little weird, so let's combine our like charges, and HOH turns into water. Now we need to use page 6 and label things. So hydroxides are insoluble except group 1. Sodium is in group 1, so that's going to be aqueous. Chlorides are soluble. Hydrogen's not an exception, so that remains aqueous. Chlorides, again, are aqueous. Sodium's not an exception, so that's going to be aqueous. And then H2O. Well, H2O is water, and unless it tells you otherwise, water is always a liquid. So there's my L for liquid on the water. Now, this is not a precipitant reaction because we didn't form a solid. So this is an acid-base neutralization reaction. And from your vocabulary, you should know that neutralization means we're going to form water. And so when we write our net ionic reaction, we're just going to have water as our product. That's the one that we pull down for neutralization. What did we use to make water? Well, if we come back up here, we used hydrogen and hydroxide. So water is not hydrogen and oxygen, it's hydrogen and hydroxide. So those are our 2 reactants. And this happens to already be balanced. We have 2 hydrogens and 1 oxygen on the reactant side, which balances it. So you don't need any coefficients. So then the spectators, the things that didn't do anything, would be a part of our aqueous product, which is Na plus and Cl minus. If you had questions as we were going through this, please reach out on Remind or email me or send me a message on Microsoft Teams, and I'll be glad to help you.